So 3 types of naming. You guys said one of the biggest challenges was the polyatomic ions and like knowing what was what and what charges they had. So first kind, ionic. If you were in my class, you learned it with hands. So everything based on where it is on the periodic table has a different number of hands. If you imagine a mini periodic table like this, +1, +2, you assume +2 for the D block, +3, no charge, -3, -2, -1, and then no charge again for the noble gases. Based on the charge, it has a certain number of hands. So if, for example, we wanted to draw sodium carbonate, look on your periodic table, sodium is Na, it's in the first column, so it has a +1 charge, which means it has 1 hand. Carbonate, anything that ends in ate or ite, has oxygen in it. It's on the back of your periodic table in your first year of chem. It's on the cheat sheet. Carbonate is CO3 2-. I will teach you a few tricks in a minute for how to remember it, but because it's 2-, it has 2 hands. So logically, we have to draw another sodium because it only has 1 hand. We can't change that. So the formula for sodium carbonate is Na2CO3. If you look at a second type of naming, instead of using hands for molecular naming, we use the prefixes. It gets a little complicated because these are the prefixes that you use in naming organic when you say how many functional groups you have. So like if you have 2 methyl groups, it's dimethyl. Same prefixes for naming molecular, but it's different than saying something like butane for organic. So these are mono, it's 1, di, 2, tri, 3. Tetra is the tricky one that everyone forgets. 4, penta, 5. So if, for example, I had something like dinitrogen pentoxide, the di tells me 2 nitrogen, so N2. The pen tells me 5, oxide tells me oxygen, O5. The probably most complicated part of naming, and something that is definitely on your test, is naming acids. Acids behave similarly to ionic in that you have to do hands for them. What makes an acid is the H+ in front of it. So anytime you see an acid, it's going to have an H+. Where the H+ is, or how many there are, depends on the hands of the anion. So there's 2 kinds of acids. There's acids with oxygen, and there's acids without oxygen. The rule is no O hydro. So no O meaning no oxygen, it's hydro. So we call those things hydro, something ic acid. For example, if I look at HCl, there's no O. So I know I'm going to start it with hydro, have a blank, and then acid. This would be hydrochloric acid. You fill it in. HBr, hydrobromic acid. The trickiest part is figuring out how many H's. So say I wanted you to do something like, what's the formula for hydronitric acid? Well, you know it has H. H has a charge of +1, so 1 hand. And you know no O hydro, which means this hydronitric comes from nitrogen. Well, nitrogen is in that 3rd 3 minus column. So there's 3 hands. So I know I need 3 H pluses to make this work. So hydronitric acid, H3N. If you look at acids with oxygen, there's 2 main things. The ending of ate turns to ick, and the ending of ite turns to us. And there's no hydro in any of these. So for example, say I had H2CO3, and we just talked about carbonate in our other example with sodium. So carbonate CO3 is a 2 minus charge. Remember, 2 H's because each H has a +1 charge. Well, if I look at carbonate, 8 goes to ick, so this would be carbonic acid. Say it was something like H2SO3. Again, 2 H's because SO3 has a 2 minus charge. SO3 2 minus is called sulfite. SO4 2 minus sulfate. So sulfite, ite goes to us. This would be sulfurous acid. Now the only reason I didn't just write sulfurous acid is sulfur and phosphorus are exceptions because it sounds funny if you say sulfurous acid. So sulfurous, phosphorus acid, those are the 2 exceptions. But knowing this 8 goes to ick and I goes to us is really important.